You built an app. You deployed it. It works perfectly. And then 10,000 people show up at the same time. That's when things get interesting. In your head, an app works like a restaurant kitchen. A user orders something, the kitchen prepares it, the food arrives. Simple. Clean. One order at a time. In reality, your app is a tiny kitchen during rush hour. Thousands of people are shouting orders at the same counter. The chef cannot keep up. Orders start piling up. Things break. Users get timeouts. And you get panic calls at 2 a.m. Before any request reaches your app, something sits in front of it. A load balancer. Think of it as the bouncer at a club. It distributes incoming traffic across multiple servers, so no single machine gets overwhelmed. Here is the catch. If your app is stateless, meaning each request is independent, load balancing works beautifully. But most apps are not stateless. They store session data, user preferences, temporary state. And if a user's second request lands on a different server, things break. One solution is called sticky sessions, routing each user to the same server so their session data stays available. It works. But it creates a new problem. Some servers end up overloaded while others sit idle. The load is unbalanced. The better solution is to add a message queue. Think of it as a first-come, first-served line. Incoming requests don't crash directly into your servers, they wait in an orderly queue. Workers pick them up as they are ready. This decouples the incoming flood from your processing capacity. Now, how do you actually increase capacity? Two paths. Vertical scaling means buying a bigger, more powerful server. More CPU, more RAM. But there is a ceiling, you cannot scale a single machine forever. Horizontal scaling means adding more servers to your pool. This is what the big companies do. More machines, more capacity, more resilience. Even with a queue, your database gets hammered by identical queries. The same data is requested over and over. A cache layer, like Redis, sits between your app and your database, storing frequently accessed data in memory. Instead of hitting the database for every request, you serve from cache. Orders of magnitude faster. And then there are static assets. Images, CSS, JavaScript files, they rarely change. They don't need to travel from your origin server every time. A CDN stores them on edge servers distributed across the globe, closer to your users. Lower latency. Less load on your infrastructure. So here is what real production traffic actually looks like. Users hit a load balancer. Static assets are served from a CDN. Dynamic requests enter a message queue. Workers process them across multiple app servers, pulling data from a cache layer and a database. Each layer scales independently. Each layer has a purpose. Scaling is not about having one powerful machine. It is about designing a system where many machines work together, each doing a specific job. And understanding these pieces, load balancers, queues, caches, CDNs, is the difference between an app that survives a traffic spike and one that collapses under pressure.